Welcome to the Base Face Network.
The team members.
Dong 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 dong
What is Reynold number?
Hello, let's get to know Reynolds number. Reynolds number is a dimensional quantity that helps predict fluid flow patterns. Reynolds number can be defined as Re equal to rho Vd over mu, when Re is Reynolds number, rho is density of fluid, V is fluid velocity, D is pipe diameter, and mu is fluid dynamic viscosity. In situation at low Reynolds number, flow tends to be dominated by laminar flow, while high Reynolds number flow tend to be turbulence. Examples of application of Reynolds number. The first one is pipe and duct flow. Reynolds number is used to determine the flow regimen in pipes and ducts. It helps in determining whether the flow is laminar or turbulence, which is important for understanding pressure drops, heat transfer rates, and overall behavior of the fluid in the system. It is widely used in the design and analysis of piping system in industry such as oil and gas, chemical engineering, and HAV, which is heating, ventilation, and air conditioning. The second one is aerodynamics, particularly in determining the flow behavior around objects such as aircraft wings, airfoils, and automobiles. It helps in predicting the onset turbulence, determining lift and drag forces, and understanding the flow separation around this object. By analyzing the Reynolds number, engineer can optimize the design of wings, airfoils, and vehicle body for better performance and efficiency. The third one is marine and naval engineering. Reynolds number is used in the study of fluid flow around ships, submarine, and other marine structure. It helps in understanding the resistance and drag forces acting on the structure, as well as the flow patterns around them. By considering the Reynolds number, naval engineers can design efficient hull shapes and propulsion system for ship and submarine. Last one is heat transfer. Reynolds number is used in heat transfer analysis to determine the flow regimen and conservative heat transfer coefficient. It helps in design and optimize heat exchanger, cooling system, and other thermal devices. By considering the Reynolds number, engineer can select the appropriate heat transfer correlation and design parameter for efficient heat transfer.
Let's begin the experiment. These are the list of equipment that will be used. 1 water tank, 2 transparent pipe, 3 control valve, 4 water receiver, 5 syringe and needle with ink. First experiment is laminar flow. First, slowly adjust the control valve and make sure the valve is half open. Then, start the stopwatch. Stop the stopwatch when the water reaches 1 liter. Record the time. Then, inject the string and observe the movement of the ink. Laminar flow refers to the particle moves in parallel layer without mixing or forming turbulent eddies. It flows at low velocity with low Reynolds number, generally below 2000. Usually, laminar flow flows at smooth surface. Second experiment is turbulent flow. First, you need to adjust the control valve until it produces a high flow by opening the valve until the end. Then, record the time of water when it reaches 1 liter. Then, observe the movement of the ink in the water flow you can see the turbulent flow. Turbulent flow is characterized by chaotic and irregular motion of fluid particles. It occurs when the flow condition exceed a certain threshold and the fluid's behavior becomes unpredictable. Unlike laminar flow, turbulent flow is characterized by the mixing of fluid particles across different layers. It has high Reynold number and usually above approximate 2000. Turbulent flow involves the transfer of energy across different length scales. Energy from the large-scale motion of the flow is continuously transferred to smaller scale through a process known as energy cascade. This energy transfer contributes to the chaotic and random nature of turbulent flow.
Conclusion for this project, fluids mechanics. After finish the experiment, we can determine the type of liquid flow in a pipe, whether it is laminar or turbulence. Next is the recommendations to improve Reynolds number application in engineering. The first one, we need to have a proper length scale determination. The choice of length scales depends on the specific flow situation. It is important for calculating Reynolds number correctly. The second one is we need to understand the flow regime transition. It is important to have a good understanding of the flow regime transition and the associated Reynolds number range, because the transition from laminar to turbulent flow can have a significant impact on the behavior of the system. Next, we need to have a precise velocity measurement. The velocity of the fluid relative to an object is a critical parameter in Reynolds number calculation. Lastly, we need to have a validation and experimental verification. Comparing the calculated Reynolds number with measured data helps in assessing the accuracy of the analysis and identifying any limitation. Thank you.